So, dependency injection. Let's make sure we all know what it is to begin with. So, if you look at dependency injection on Wikipedia, you'll find it's very kind of hand-wavy, academic, very correct definitions of what it is. I'm not going to use one of those. I've got my own, which I've derived from the day-to-day process of dependency injection and the pressure that I exert on my code. And that is this. So dependency injection is the practice of replacing hard-coded classes or types with dynamically configurable objects. Now the really dumbed-down version of that is don't put class names inside of the classes. Very easy. So, do you guys know Sandy Metz? The Prudy book. So, I don't think this phrase is in the Prudy book, but to paraphrase something that she said, every time you put one class name, another class name inside, when you name one class inside another class, you add a dot of glue to the model that your system is trying to replicate. And a certain amount of glue in any model is necessary, but too much glue and you end up with a sticky, rigid mess that becomes very inflexible. So why is it useful? I'm going to make some claims. It enables true isolated unit testing. So isolated unit testing is something that is really important to me. I think it should be important to all Rubyists. So what do I mean by truly isolated unit testing? What I mean is that when you run a test for that object is the only object that's loaded at that time. There are no other classes, there are no other objects involved. It is purely just the one object that is on the test. All of the collaborators should be replaced with test doubles. And again, later we'll see that I think this is actually only truly possible if you use dependency injection. The advantage of doing that, apart from speed, so there was a lot of stuff a few years ago. There was Gary Bernhardt and Corey Haynes talking about the speed advantages of isolated unit testing. You take your code out of Rails and your tests run in milliseconds, which is brilliant, and that's definitely not to be underestimated as an important advantage. But the real advantage for me is that you get a very high quality, high clarity feedback to your design. So as soon as you start to do something wrong, those isolated unit tests will start screaming at you, and they'll be saying, no, you're doing something wrong, you've got too many collaborators, you've got too much behavior, blah, blah, blah. And really, it's that quality and clarity of feedback that I think is really important. So that's something we'll achieve with dependency injection. So it increases reusability of individual objects. Now you might think, oh, well, I don't generally reuse my objects. And that's kind of a self-fulfilling prophecy. If you don't design for reuse, it's no coincidence that you'll find that those objects are not reusable. So, just have a think about how many times a class was used for something that wasn't originally intended. Also think about the open-close principle, where your objects should be open to extension, but you shouldn't change them, ideally, once they've put into production. Finally, it loosens coupling system-wide, and this is really just the previous 2 points on a macro scale. So, thinking about the first 2 points for each individual object, when you apply this over a whole system, you'll find that you have this loosely coupled system of components that will just plug into each other, plug and unplug. And it's really good for maintainability. So this is what I'm saying. So we also like global variables in the Ruby community. And we might not think we use global variables, but bear with me a second. So in Ruby, constants are all global. And in Ruby, you can also overwrite these constants. And generally in a Ruby app, we create classes and we store them in constants. So classes and global variables, while semantically different, functionally they're quite similar. And here's 3 ways of defining a class. The first one is the one that we always use. The second one is what actually happens. So you say class foo, it creates a new constant foo and puts a new class in it, and the class gets the name. The second example shows you exactly that's what's happening, and that was my favourite. And if you want to talk about bike shedding of class syntax afterwards, let's do that. I love it. One of my favourite things. And then the third one is kind of just a weird one that I threw in. I don't think anyone writes code like that, but it's functionally equivalent. It will work just as well as the other two. So you've got classes which are essentially global variables that you hard code everywhere. And you also have this problem with monkey patching. So we frequently write code, like that, just that little snippet there, where in order to test that code, we import a library such as RSpec, and that does this stubbing thing for us, and we just call user.stub, and we're quite happy with it. It looks nice and tidy. But actually, the code behind that is crazy. I don't know if you opened up RSpec and had a look at the implementation of stub. It's mental. You would never write that code yourself. It would never get through a code review in any of our companies, I'm sure. And it just seems a bit mental that we write code this way. So all I'm saying is, I'm sure we can do better. So this is my application, Fruits of the Month book. It's just an application that I've dreamed up. It faces many of the problems that we face day to day. So it's a Rails app. It's pretty simple. Box of fruit every month, and the fruit changes. And we're really confident it's going to be huge. So the first feature is which fruits are in season now. And that feature just boils down, it's very simple, but really all it does is it boils down to a scope. We're going to select a subset of fruits from the database. And this is how my crack team of senior Rails engineers with 2 years of experience have decided to do that. So this all looks pretty reasonable, and this is just a really simple example of dependency injection, so bear with me while we get the easy one out of the way. My issue with this is that the date class is hard-coded in there, which seems pretty innocuous, but let's have a look at what might be wrong with that. This is the test. The first thing that happens is the fruits seed the fruits. These guys, they're hilarious. There we go. We seed the fruits, put them in the database. We stub out the date to be a date in the summer, and we expect that the fruits in season in the summer will include summer fruits and exclude winter fruits. So pretty straightforward. My issue with this is that what's actually happened is we've written some code that can only be tested with monkey patching. There's no, apart from change the system tangle, which would be arguably worse. The only way to test that is with monkey patching. So I'm sure we've all used timecop. Probably, yeah. This is a naive version of what timecop does. So you give it a time, it stubs out all of the date and time objects that Ruby has, so you consistently get an artificial time back. So this is just a simplified version of that. So my issue really is that we've written code that we have to import a gem, a monkey patching library to do a monkey patch for us that is potentially too tricky for us to do ourselves. So we've written code that we can't test ourselves without the help of the library. Just seems a bit crazy to me. So let's have a look. Skip through all this. The point that I would make is that Ruby is really good at this. Ruby is really good at monkey patching, and we can get away with a lot, and I think that's why we kind of cope with the current situation that we're in. So this is the same code with a small change. And all I did was lift date up into into here as an argument. So you can pass in any date you like. the old code that calls into this won't break because it defaults to date.today. And if we look at the tests, we'll see that we must have done something right because the tests are less complex. Now we just have string here instead of a whole load of monkey patching. And we also have more added flexibility now, so we can put any date in here and we can test it against, we have a huge fixture file of fruits and when they're in season and check it against the fixtures. That's obviously overkill, but it could be done if it was necessary.
I think there's something that the one thing that jumps out there is whatever, it's something I was trying to emphasise, is that your tests are now less brittle. If you start using different functions around the day, whatever you choose to do with that, it can still pass the tests that you have, but your tests don't need to change. Like if your monkey patch are stubbed out today, then anytime you change it, it will be assuming you change the test.
That's a really good point. It's a lot less brittle, and actually, in the previous test, this line here is actually exposing my implementation. So my test was really coupled to the implementation as well. Whereas there's not really any need for that because all I'm doing is taking the data and casting it into a string for whatever kind of ORM I'm using. Whereas here this is just a string. It's being cast to a string, so it's a lot less coupled.
To throw a bigger sort of danger of that is, it looks like, let's see, I suppose you're passing a data. Let's say it was like maths, right? Mm-hmm. And you had like 1 plus 1, and the requirements were that equal 3. You could still have a plus function to return 3 in your test. And that's complete nonsense, but that's your maybe misunderstanding of the requirements.
Yeah. It'd be more like if you had a function that added 1 to something, so you could stub out the plus function on 1, because the 1 would be hard-coded in there. Obviously, if you're passing both arguments, you're essentially injecting any dependencies, but yeah.
So it also refers to the sort of unreadable homework that you're stubbing out the test, what your implementation is. So it's like, I think the result of this will be flat, and that's what I would return the stub version of the test.
Although also there's the risk slightly, maybe it's because it's a little example that you've done date.today wrong, and in fact that's always going to return the epoch, and it's always going to be the wrong season.
Right. I think those tests would cover that.
Okay, well, they pass it in. They pass it in as most every checking for the current day.
You mean never pass in, just let the parameter be equal, you never actually do that.
Oh, right, no.
So if you've done date colon capital today as a module instead.
You mean in the default?
If you just that, then okay, you've got bigger problems, but it's like
absolutely. So I'm going to come to this point later, actually. So well done. I wouldn't do any of this in a unit test, but I would have my integration tests hit that code path that didn't pass the data and got it defaulted. Because when I'm running my integration tests, I don't have to worry about dependency injection because I'm just executing the whole stack. Very true. But that code path would be executed, so we would be safe. The other point I'll make actually while we're on this example is that this code only works for today. If I want to find out what fruits are in season tomorrow, I can't. So this is actually the previous version of this code is actually quite functionally limited. So by adding the dependency injection, we've actually made it much more reusable.
I've got a binary log equal from both sides. Sorry.
Those were the requirements of the client. I'm going to say. I'll look into that. Sorry. The next feature would be a fruit search. So it's for the concept. This is going to be quite a complex feature because we've got a huge fruit catalogue with lots of different attributes. So there's things like origin, sweetness, colour, loads of wacky stuff. And you know, my team come up with something like this. So it's a complex fruit search, and I've kind of told them up front that we can't have lots of logic and controllers, and we can't, you know, fat models didn't work either. So we're going to go straight to this service object type thing, and all that is just an object that encapsulates the complexity of transforming those parameters in querying the database. So this is the implementation they come up with. And it looks reasonable, apart from, again, there is a hard-coded dependency in there, which is fruit. Now, fruit, in a fruit search, you might think that's pretty harmless, but as we'll see, there are genuine problems with it. So fruit happens to be an active record, which makes testing slow. So whenever I want to test this, I have to wait 5 seconds to, what's the worst you guys have had? Minutes. Minutes. Nightmare. Total nightmare. So that's a big problem right there. And it's not open to reuse. So again, we come back to this reusability argument, and it might not be completely obvious as to how we would reuse that class, but I've got a good example coming up which we can think about. So the boss comes along and asks for a small change to this feature. And it's scoped search pages. And what he wants is a scoped landing page for every type of fruit to appeal to different demographics within the market. So exotic fruits, seasonal fruits, and seedless fruits, for example. So how do we do this? There's a little code sample. So this is a kind of a halfway house of dependency injection. And the line that I would ask you to have a think about is this one, with the options.fetch in there. Does everybody know what fetch does on a hash? Okay, so just to make sure, if you pass a hash in that has the key scope, it will just return whatever the value is. If it doesn't, it actually executes this block and returns the value from that.
It's essentially a complicated version for options with a square bracket.
It's a complicated version of square bracket.
But the last thing. But that works with Boolean?
Yes. Among other things. Yes. You could have a nil in there and it would come back nil without executing the block. The cool thing is, if you do pass it in and the block isn't executed, Ruby doesn't mind that you didn't require fruit at the top of the file. So the fruit class doesn't need to be loaded. And as we said, that's an active record, which takes a long time to load. So by wrapping it in this lazy loading block, you can actually test this class now by passing in a double for scope, and you've circumvented all of your testing problems. Well, all of your testing problems. That one particular testing problem. And it's kind of reusable as well, so we can pass any scope in that we want. So we've added some flexibility in there. The disadvantage, and the reason why we call this like a fake DI halfway house approach, is that we still have the burden of knowledge that it's a fruit that it was looking at originally. And I think we all know that we want our objects to have as few reasons to change as possible. And this, I think, is a glaringly obvious extra reason to change. So this is a great technique if you work with a legacy code base and you haven't got lots of extra layers to put your dependency and injection bits into. You can just use one of these hash fetch things and get most of the advantages. So one last thing, this always happens. We've done the whole thing, we've shipped it, it's Friday, we're just walking out the door, and the boss wants one more thing. So, love the work on fruits. Now we're going to do vegetables. So, okay, this is awesome, the developer says. You know, we've been using DI. It's been great. We should be able to implement that really easily. Unfortunately, no one cares. So, let's have a look at the new vegetables search controller. And the difference here is that we've generalized the fruit search to a produce search. It's fruits and vegetables, in my mind, generalized to produce. So, we're passing in the scope, as we saw in the last example. We can pass that in with the parameters as well. So this is looking pretty good, and the produce search is pretty much the same as the original fruit search. So it didn't take, we didn't have to hack the system to pieces in order to get to this point. Now the problem with this is that there's still a lot of class names in here. We've got vegetable, complex produce search, vegetable, complex produce search. So I'd like to do a refactoring on this, and I would suggest this intermediate step. So now we've cleaned up all of the class names here. So these are all just these could be anything at this point. They're not tightly coupled to their collaborators, and we've pushed all of the class names into one place here. So the nice thing here is that this instantiates and configures the vegetable search for the produce search, for the context it's going to be used in. And then the burden of knowledge about all of the classes and all of the implementations and collaborators in the system is now removed from these two methods. So this would be the implementation of that complex produce search. Pretty simple, passing a type, passing the scope and the params. We've removed the block from the fetch now. We don't need it because we always pass in the type when we initialize the object. So we've sorted out that last annoying reason to change that we had in there. This is the other behaviour of the fetch method. The second argument is the default when you don't need a block. So if it's just a primitive type or a string that you don't mind always being evaluated, you can just put it as a second argument. The all symbol would work just as well in a block. Obviously there's overhead in creating a block in Ruby, so it was better practice to do this one as something simple. So moving on. Two important things just happened, so we just need to take a step back and look at the concepts that come out of that. A hard-coded dependency became a runtime configuration option. So when we run the code, we pass in the types and the collaborators that we're going to work with. An object comes back, we don't necessarily know where from, and we interact with it. We eliminated the default value and decoupled from the specific class name. So I don't know if you guys have read Gamma 4, but there's a thing that they said that's quite important, and that is programmed to an interface and not an implementation. So I'm going to translate interface and implementation into Ruby for you, and I think it's this. So we don't have interfaces, sorry. We have duck types, and we have specific types of duck. So ducks and mallards. So complex produce search is a mallard. Fruit search, if we have this code, would be a duck. So this is what we want, ducks, not mallards. The other advantage of doing this is that the ducks and mallards can have different names, which we'll see is a good thing later. We can name our classes according to the implementations. So we could have several different implementations of the produce search. We could have a complex solar produce search when we decide we need to move over to a more scalable platform and not just do a full text search in the database. We could then seamlessly swap that out for the original complex produce search, or whichever new technology we wanted to implement. And rather than trying to shoehorn one into the other, we can just name our classes very explicitly and not leak that implementation detail into our code, which would not need to change at all. and then we name the collaborators according to roles. So this could be very implementation specific, and this is basically your interface name. What kind of thing are you interfacing with? It's a fruit search, and I don't care what it is. So yeah, that's all very well, but yeah, most apps I've seen, mallards have gotten everywhere. It can be a mess. So how can we get rid of some of these class names? So we'll just go over something that was kind of implicit in my examples there, and just make sure we notice it. When you construct an object, like the complex project search, you've got a few options. You could write that as a class method, and that would be the class method version, right? We just call results on the class, or it could be a module even, and pass the things in. But it's not OO. It's more like a namespace procedure, and the implementation will actually be quite hard to refactor because within a class we don't have at the class level we don't have instance variables, and you just end up passing around all the values, and it ends up looking very procedural. I pretty much never write a class method ever. For me, the only class method is new. That's the only one I like. I think that's a good thing to stick to. The other way we could do it is pass everything into new. I actually think this is perfectly valid, but it doesn't help our situation. If we knew up one of these searches and call results, we're never going to call results twice. We get an array of results back, or we could get a result set object back with some sort of enumerable interface. But we're never going to ask that result set twice. So I don't think this necessarily makes sense for our use case. And the other problem I have with it is that the client, or the creator of this object, when it's instantiated, needs to know everything at once. So you need to know about the fruits that are in season, which is kind of a compile time kind of thing, and the parameters, which doesn't happen much later till the user input arrives. So this is what we have to do, separate compile time and runtime dependencies. Ruby doesn't compile, but can we say load time? Something like that? I don't know. But I think we all know what I mean by compile, so I'm going to stick with that terminology. So now we do it like this. The fruit type is known well in advance. We knew of the object with the type that it's going to be interacting with. And then the data, which is basically from the user, this is from the context that it's used in, and this stuff comes directly from the user. That comes in later. So what we actually do is separate the instantiation from the invocation. So we can do this bit much earlier and do this bit much later, which really helps for configuring objects, passing it in, and then using it. So what you really want is instantiation as a separate concern, and this is kind of what dependency injection is all about. So the code I had before, I factored out all of the class names into a private method in the controller. But the class names were still in the controller. They were just sort of all packaged together neatly. What I really want is to get rid of that. That's another, just as it was a reason for my fruit search to change, that is a reason for my controller to change, and I don't want it. So the code I really want is this, and nothing else. So I've introduced another variable here, which is this app thing. So no instantiation, which is great. All we're doing is calling stuff. So no mallards, just it's all ducks. What's app exactly? So this is another thing that I've been experimenting with. Your app can be an object too, and that's to say, you can have an object which models your application. You can have a method per service that your application offers. So you could put this maybe at the top level of your app directory, open that file, and here's a list of, say, 20, 30 methods. This is everything your app does. And in my system, this is the one place where class names can be found. So I just push and push and push them until they all end up here. I can just call into my app for a veg search, and it's already dealt with all of the dependencies and given me a configured object to use, which obviously makes the rest of the objects a lot simpler. So, I don't test controllers. I don't unit test them. I just it's up to an integration test, because you can't unit test a controller. It's just not possible. You can use the RSpec Rails tools, which give you the illusion of unit testing a controller, but really you just have so little control over that object, and it's just so massive. So I take all of my real application logic and stick it in various service objects, which are instantiated by the application object. And then I can unit test all those very neatly, and my controllers just end up being one call out to the application object of, I need this interaction to happen, and here's the data. And then give me something back and tell me what to do, tell me what to render.
So would you have your app set up in some initializer?
Yep, that's coming. Yeah, I'll get to that. Very astute audience, way ahead of me. So we don't test this. This is very much kind of an integration point. There's no logic here. It's just plumbing basically. So we just have simple factory methods, and it's essentially a config file. So if this was the 90s and we were doing Java, this would be the most awesome XML file. Well, this doesn't need to even be code. We can just, write this in text and parse it, and we'll probably don't do that. And this is the service locator pattern. If anyone's heard that one. Keeps all your mallards in one place. So how do I get this into Rails? Very good question. So I do this, and I'm not massively happy with it, but I can't think of any other way, because Rails is very hostile to dependency injection. There aren't any points at which you can inject your own objects. So I tend to just new up one of my applications, and then I wrap the constant in a method here, and then this protects the rest of the app from knowing that I did this nasty thing here. If anyone has better ideas, please.
There is a way of doing it if you want to keep that good. If you want to do it right. That's where you go. Purpose. What? You can. I did a kind of the proof of concept this last year,
right?
Where I multi-patched the object controller creation part. It was actually creating an instance of the controller, set it all up. You can kind of crowbar something in there just to inject constant or something. What? I'm just saying you can. I'm not saying whether you should or not. Yeah. But you can.
I think if you get your app very decoupled from Rails, that's the kind of thing that wouldn't be out of place in a kind of Rails adapter for your app, which is that they're actually the kind of apps that we build. We're not actually using Rails at the moment, but I don't know, the simplicity of that versus the trade-off of, okay, there's a global constant floating around.
Oh yeah, it's a hell of a lot more code, just those three lines.
Yeah.
I'm just saying it's possible.
So yeah, we should argue about that. That sounds like a good thing to fall out over.
Don't argue with me.
Obviously you can. Right, so that's some examples of dependency injection, some of the issues that you run into if you don't use it, the advantages of when you do, and hopefully some advice about how to get into Rails. So now, just to finish up, I've got some functional kind of tricks, which I do use all of these in my production apps, and they're really handy, but they're not too commonplace in Rails. So if we imagine we've got a service object that creates a user, this is again a very similar situation. It's a create user class, and it has user hard-coded in there. So we want to get rid of that. So now with DI, let's refactor that. So very simply, we can pass in the user class, and that achieves the goal, that ticks the box of remove all the classes. But it's still very coupled to the class level implementation. Regardless of what this is called, I just call the user class to be very obvious about what happened. When we call this new method here, I think we all know that there's one thing in Ruby that you call new on, and it's a class. So this isn't really the duck type that we wanted, because we're always instantiating classes. I mean, you can do hacks and override the new method and have it return something else, but really, it looks very class level implementation, and we want to get away from that. So, very small change. I'm going to change user class to user builder. We can equally call that user factory, but we don't like the F word in Ruby. So it's a user builder. And instead of new, I've just replaced new with call. And if you indulge me for a second in my fantasy land, I'm just going to change that to call without saying anything else. And this code on its own, considered on its own, seems quite good. But surely we've made things a lot more complicated for ourselves because we've changed this new for call and we can't pass the class in anymore. So let's have a look. Sorry, user builder can be anything with a response to call. In Ruby, and in Ruby this is props, blocks, and lambdas, or any object you implement call. So yes, the difficulty, we can't pass the class in directly anymore. So let's have a look at what we do. We're going to use the method. I'm going to say method a lot of times on the slide, so just bear with me. The method plucks a method from an object, as we see here, and returns a method object. The method object responds to call and behaves like a lambda. It doesn't lose its binding like in JavaScript. So in JavaScript, this is a really common trick. You pass a function in, and the function that you pass it into calls the function. We don't do it in Ruby so much. In JavaScript, if that's a function from an object, it'll forget what this is. In Ruby, that's not the case. Use the method new, and then calling that method object will behave exactly like calling user.new. But obviously nicely abstracting the concrete implementation of where that came from. And it's also easily replaced with a more complex object later. As we just saw, the call protocol is supported by props, blocks, lambdas. So you could chuck a lambda in there. You could write a class and implement a call method and chuck that in there instead. And then the create user service that we saw before wouldn't need to change. So there you've got your open and close principle satisfied. The other cool thing about this is that it's very extensible to arbitrary levels of complexity. So you might think we've got more than enough layers at the moment. We've got Rails, we've got the service object, we've got the service locator, and then we're plucking a method off a class and passing it all the way through. But systems always get more complicated than we thought they would. And you can just stack objects on top of objects if you handle it like this. Not that you want to, you wouldn't aim for that, but it gives you the ability. It's also a great trick for interface segregation. So interface segregation is the I in solid. You guys are familiar with that, but that's the I in solid. And what that says is that an object should not have to depend on methods from an interface that it doesn't use. So if you pass in a whole user class, which might be an active record, how many class methods does an active record have? I think it's in the hundreds, isn't it? It's probably a couple of hundred class class methods and a couple of hundred instance methods. Sorry? Yeah.
What about not using active record?
How about not using active record?
Yeah. I'm using SQL these days.
As am I, actually, yeah, it's working out very well. Even with SQL, that could be a SQL database mapping, and it would have, sorry, not a database mapping, it could be a SQL model equally, which is another active record implementation.
It seems you're looking to make lots of little sort of ship objects that connect to other things with different APIs.
We actually have a mapping from ordinary objects to SQL objects. We can just test the models in memory of that as well.
Yeah, it's a great way of doing it, absolutely. But yeah, so the kind of the trick with this is just that you don't need those intermediate kind of useless objects, which you might have otherwise been forced to write. We've got a few nice tricks in Ruby to make this whole DI thing pretty seamless. The other thing I really like is currying. Do you guys know about currying?
JavaScript.
Yeah. JavaScript. I heard about currying in JavaScript now. I think that's a new trendy thing, isn't it? It's more of like a Haskell kind of functional hipster type thing. So if you curry a proc in Ruby, let's say it's got 3 arguments A, B, C. You tell it to curry, and it will return another proc, which you can call with an arbitrary number of arguments, up to 3, and it will let you call it as many times as you like, up to the point where it's collected all of the necessary arguments. So in this case, we call it, and call it 3 times with A, B, and C, and it's not until you call it with the final argument that it actually kicks in and evaluates the proc and returns. So if we think back to when we were constructing our objects and separating the dependencies out, you can actually do the same thing with currying. You can curry. You can take a method, as we did before. You can curry it, and let's say the first argument is a compile time dependency, and the rest of them are just data. You can call it in the service locator with the first bit, and then chuck the other stuff in later. It's all about changing the timing of when the arguments have to be there, because you shouldn't have to know about all of the dependencies. It only works with positional arguments, and I really like hashes and keyword arguments. Both your FP and OOP friends will think it's cool. There's another advantage of this. And no one will notice that you've actually made a factory, which is another nice sneaky thing. Coming in Ruby 2.1 are required keyword arguments. So Ruby 2 has keyword arguments, in case you didn't know. And Ruby 2.1 makes them useful by making them required. And this is the syntax for it here. You just don't put the default, and it's quite hard to accept that. And it will raise a nice argument error, missing keyword 2, which is exactly the kind of, for me, this is the best possible argument error imaginable. Rather than, I'm sure we've all had argument error 3 for 4. Did I need 3 or 4? Which way around is it? No idea. So, I'm a really big fan of these required keyword arguments. So much of a fan that I wrote a gem. So, if you want to curry your keyword arguments, there is a gem there for you to have a look at. And in the same way that currying worked before, what happens is that I'm afraid there's a monkey patch in there, but it's explicit. You have to ask for the monkey patch. So rather than just wait for the right number of positional arguments, it will actually wait until all of the required keywords have arrived, and you can call it as many times as you want. And it will just sit there waiting, collecting all the arguments. So when all the required ones are there, it will finally call the method. So the previous example of currying, we had a proc. Only procs can curry in Ruby. And when you have a method object, it's not actually a proc, but you can to proc the method object. So you get a method object into a proc, then you can query it, and then you can call it multiple times and separate the timings of the arguments. It's wonderful, isn't it? Obviously, you wouldn't have. I mean, yeah, this is a bit silly because it's all here at once. But the point is, you don't do it all at once. You know, you do it up to this point, and then you pass an object, and all you have to say is, "Oh, well, who am I saying hello to?" Oh, it's ScotRUG. That's ScotRUG. In a real context, I probably would have had a better example of this. I literally did this on the train today.
So see if you call the first call from investigate, is that pretty much returning some sort of temporary call proc around to say hello? Is that what's happening? I'm not quite following.
Oh, okay. So yeah, what happens is Curry returns a proc, which is an abstraction on top of the real proc. So I mean, forget about the method to proc. Even if you just define a proc which responds to query, it will give you like a wrapped proc. And then when you call that proc, all it's doing is it's collecting arguments. And it will say, do I, now I've received argument 1, I'm going to wait for argument 2, and then you can actually give more than one argument at a time as well. You're not restricted to one argument. And it will just wait until, argument 1, argument 2, argument 3, now I have all of my arguments, I will return. And it calls the underlying proc.
You're talking about building your factory waiting until you've got arguments.
Mm-hmm.
Would it be the case that, for example, say you know who the message you're saying hello from?
Yeah.
Would you hold on to that proc till later in the system when you know who it's going to go to?
That's right. Yeah. So if this was some sort of messaging app, when I log in, I can just give you a message sender, and all you have to do is tell me who to send it to, and you don't have to worry about this other dependency.
Or you can do the opposite and send a message and wait for content or whatever.
Yeah, absolutely.
It's pretty slick.
It's a cool little trick, yeah.
I would get shot if I used this at work tomorrow.
We're not on Ruby 2.1 yet, unfortunately, but we do use the old style querying in our apps, and it works really well. It's a really neat trick. So yeah, when you go into Ruby 2.1, give this a look. It's good fun. Last thing, while I'm kind of on shameless gem self-promotion, I also wrote this one because fetch is one of my favourite methods in Ruby. Love it. So I wrote this gem which will add a fetchable interface. It's a mixin. Add a fetchable interface onto any object. It also comes with a decorator if you're into composition over inheritance and things like that. Definitely worth a look. If you like the whole proc weirdness thing, I think I've given you a taste for it. You can call procs with square brackets as well as call. It's completely equivalent to use square brackets instead of dot call. So you can actually mix in the fetchable interface into a proc because fetchable delegates to square bracket. So you can fetch a proc, and then if the proc returns nil, it will blow up. And it'll say, "Oh, not found," or you can use the lazily evaluated block in there as well, which is a good one. To summarise, DI can help you with more focused and faster testing, more flexible code, and code that can do different things when introduced to different collaborators, giving you reduced need to change existing objects, which helps with things like open, close, and all the solid things. So the ones I've focused on here are the O, I, and D. So that's open, close principle, interface segregation, which we saw with the method, and obviously dependency inversion, which dependency injection is a method for doing. I really think that starting off with something like dependency injection, all the other solid principles and all the kind of highfalutin maintainability and object design things, they all just seem to fit together, and you just want to do more of it because your system gets so flexible and so nice to work. So you can start today. So these are my kind of tricks for legacy code one more time. I think this one's more popular than the hash fetch, actually, right? I prefer the hash fetch massively to this. You can stick the default argument in. The default argument is not evaluated, so you don't need your Twitter client loaded to test this this hateful class.
Don't try that method with delayed job. It just won't work.
I'm sure dependency injection just doesn't work with delayed job.
No, using passing in an object, it's just like that with the delayed job causes it to explode.
It's all like class level before.
Because it gets serialized to YAML and then ends up with a method call, and then you know how people are sensitive about that these days.
Yeah. What really winds me up about queuing frameworks is that they all have silly method names like execute and perform. Why not call? You could have like passed lambdas in and stuff like that, or method methods. You know, it's just no fun. So this is my preferred version of doing it. So yeah, you can crowbar this into your legacy code today, hopefully. And that's all. Thank you for listening.